This is a tube tester I picked up on eBay, the EMC model 205, made in 1945, I believe. It's pretty beat up. The sockets are pretty much shot, and the parts inside are not in the best shape either. But I bought it because I want to build a audio tube tester, which will check for microphonics and other tests under full load or nearly full load conditions on the tubes. So that's what I'm going to build inside of this box here. And I have to strip all of this wiring and sockets and old parts and so on out of here. So here we go. Okay, I'm going to take this thing apart. Going to reuse just the tube selection switches and the meter and the knobs, and that'll be about it. The rest will be all new parts, and I got a lot of boards that are going to go inside of here. Okay, I got the panel cleaned up pretty good. We're also going to clean up the wooden case because it's got a lot of rust and dirt on it. It'll take some sanding, but I want to get it looking real nice too. Take all these pieces off of here and refinish the case. This is the refinish look. Sanded it down and got it stained and polyurethaned. So we're ready to start building the audio tube tester. This is a block diagram for the tube tester. We have the socket unit here, power supply, 400 volts DC for plate voltage, about 6.8 volts. That is diode drop to give 3 selections of filament voltage, but it starts out about 6.8, then down to 6.3. It depends on the current of the filaments of the tubes where you would select this switch here. Variable plate voltage circuit to give you 0 to 400 volts. Variable audio oscillator. It's set up for 1 kilohertz or 10 kilohertz to put a signal into the grids of the tubes. We have a X-former boost, plate transformer boost circuit here, because this is the actual plate transformer for the power tube test, which goes into 8 ohms, and that voltage is a little bit low, so we stepped the voltage up here just to give the meter a little bit better resolution. AGC board for the microphonic testing. A VU meter drive board basically drives the meter with audio, takes the audio output from the tubes and rectifies it to give a meter reading here. And an audio power amp just for the audio monitor jack and the internal speaker. We have the meter selection here. This selects the different tests and feeds over to the meter. That's the basic block diagram. Most of these boards already exist in other projects, so I might use all or part of these boards. So now it's time to put everything together. Okay, I've built up the socket board for the tubes. It's ready to go. I'm going to set it up on the bench first just to check a few things here. I've got the plate transformer there and the power supply. We're just putting a few signals through just to make sure that things are looking halfway decent. Here we're getting the panel kind of built up here with some of the wiring, and we'll have lots of other boards on the base here. We've got the switches connected pretty good. This is the VU board and the AGC board. So there's lots of boards in this to bring it all together. So hopefully it'll all work, and the noise as far as hum and things like that won't be too bad, because there will be a lot of gain in this thing. So there's the completed wiring unit right there. So it's time to do some preliminary testing. I ran some quick tests on various 12AX7 tubes just to get an idea where the meter is going to reside. And also wanted to check these 15 different brands of tubes. A lot of these are what they call new old stock. Some are just old stock, period. This is what the meter reads on the tube tester. So we're about 36 to 37. Looks like 37 is pretty much the average meter reading on the 12AX7s. And then we test section 1 and 2 of each of these tubes. We got some Mesas, Bogans, more Mesas, Raytheons, Amperex, Pentron, Fenders, National, and so on. 3 of the tubes were microphonic. Bogan was, this Pentron was, and this RCA was here. So we have 3 microphonic tubes that I'll show in the video of how the tester finds those. This is my homebrew tube tester, mainly to test audio tubes. And it actually puts real high voltage, real bias on the tubes to put them in a closest as possible real life condition. Right now I've got a 12AX7 in here, and this one's microphonic, so I already did some tests with that one. These are the controls here. Got the filament voltages. This is for testing the power tube's screen voltage. We got 2 settings for screen voltage, a high and a low. Meter current for the meter here. 10 times the number and 1 times the number. These are for future use, these 2. This is the elements. So like a 12AX7, section 1, off, section 2. And there's a section 3 here for like a 6U10. That's a 3-section triode. So you can plug a 6U10 in here and test those. Input, that sends the oscillator to either the pre-tube setting, which is pre-tube basically means 12AX7s, any type of preamp tube, or the power tube. And that puts the audio oscillator, selects which type of amplifier tube you've got here. This is an AGC, and what this does is when you go to the noise to measure the microphonics and so on, it adds a lot of gain so you can hear the elements inside the tube as they vibrate. And this is the in and out for that. The monitor is either pre-tube, which 12AX7s and so on, or power tube, which would be like a 6L6, 6V6, whatever. And then you can read the oscillator, which just kicked in just now. And it's the oscillator at the moment is set for 10 kilohertz. There's 2 settings for the oscillator, 1000 hertz and 10 kilohertz. So you can kind of take a look at the gain of the tube at the higher frequency to see if there's any roll-off to speak of. And there's a scope output here. This sends to a BNC connector, the pre-tube output off, power tube output, or monitor out. Monitor out is basically what's coming out of the audio out of the headphone jack or the internal speaker I got mounted in here. So anyway, that explains all that. On this side we got a switch selector for filament, and the filament it's like a 7 volt, and then there's diode drops to bring it in depending on how much current the tube draws. So that is set by the center of the meter here. So like right there's the high position, and for this 12AX7 I got sitting over there, it's a little much. So we put it in the medium position, and this should be right dead center, and that'll be 6.3 volts. And the low position, it's a little lower than 6.3. So use the medium position for a 12AX7. You'd use the high for like a 6L6. So that stays medium. Then plate voltage. And this will do up to 400, a little over 400 volts plate total. The measurement is here in this position. Turn the plate voltage on, and this varies the plate voltage. I'd turn the current meter on. So for a 12AX7, set it for 300. So the 30 here means 300 volts. And you can turn that on and off when you're switching tubes. So, and then plate current is the next setting. Then we have an open position here because we don't want the plate contact next to the other, so it won't jump. We don't want it to jump across the pins of the switch, so there's an open position. Then output noise, output/noise. So this is where you read the output. If I go to section 1 and pre-tube, monitor, pre-tube, and this is the oscillator at 1,000 hertz, and that's the gain of the tube. And you can bring the monitor up to hear the 1,000 hertz. And this, if I flip this is 10 kilohertz. You can see the gain drops just a little bit at 10 kilohertz. And then by kicking off the input and you adjust the monitor level and turn the AGC on, this is where the microphonics comes into play. And you can hear it because this particular tube is one of my test tubes for microphonics. Section 1, section 2 is quiet. So, and lastly, in order to have the gain be consistent, by putting this in the oscillator position, here's where you adjust the oscillator level. Right now it's at 1,000 hertz. And there's 10 kilohertz. So when you go to the test mode, it makes sure that the gain, the input to the grid of the tube has a consistent setting for the oscillator level. And then when you go over here to test, and the tube as it being a 12AX7 should be between 35, 36, about 36 and a half to 37. This one is microphonic, but you don't notice it till you really listen to the gain, put the gain into it. Then you really notice it. Okay, got a 12AU7 here. It's a much lower gain. As you can see, it's pushing 21 here. They're all around that point, but section 2 is much lower. It's about 18.7 or so. So there's a gain difference for one between the two sections. Again, it's a 12AU7, so it wouldn't have made a very good phase inverter tube like a lot of these are used for. We're going to check the noise now. Section 1 is okay, not too bad. Section 2 has got a lot of grid noise. So that tube is not very good. And that's section 2 is the one that had the lower gain too. So that tube is trash. Okay, this 6U10 says low gain and noisy. I just happened to pick some bad ones out just to test. So let it warm up and set it up for steady tone. And hit the plate voltage. And section 1's running about 19 like the other tube was. Yeah, section 2, the 12AX7's running much lower. It's running 30, 1, 2, 3, 33, maybe 33.1 or so. And then section 3 is running 20. Section 1 is running 19. So not a real good match in this tube. We'll go ahead and do the noise test. See what we have there. Maybe a little microphonic on section 1. Ooh, there's section 2, the 12AX7. I can even hear the hiss coming out of there. It's not microphonic, but it's sure hissy. And section 3. Maybe a little bit microphonic, but Sounds like section 2 is loaded with noise. Yep. So anyway, there's a couple of 6U10s checked out there. Okay, we're going to try some power tubes here on the tube tester. Got a 6L6 here. This is a Mesa tube. So we're going to set up the filament, and that'll probably be on high because it draws quite a bit more current. So we're a little on the high side here, but that should work out. Plate voltage, we're going to go 400. So that's about the max I can do here is 400. Screen on low. Can put the plate current on 1x. There we go. And that's 20 mils exactly. We got 20 milliamps of plate current. And we set the oscillator level. And we measure the output here. And that's at 1,000 hertz, and we're sitting at about 32 right on it. 10 kilohertz. It's got a little bit of a boost to it. Now there is an actual plate transformer set up single-ended on these power tubes. So the frequency response of that little transformer probably isn't the best at the low end especially. But that's why I pretty much just use 1,000 hertz as a reference. And everything can be referenced then to test these tubes out. Now we go for the noise. Take the input off the oscillator, we put on the AGC, and there's the gain. And there's a little bit of microphonic, but that's a lot of gain for this. Oh, you don't hear like grids bashing into each other and stuff, because the power tubes really don't have a lot of gain comparison to the 12AX7, so there is a lot of gain here. That's the 6L6. We'll turn off the plate voltage and we'll try a different tube now. We've got a groove tube 6V6, so we're going to try that one out now. Okay, filament. It's a little on the high side there. Let's try a medium. Yeah, medium looks like a good spot for the filament. Let it warm up a little bit. Power tube here. Set the plate voltage at 350 for this one. Plate current 1x. Screen low. So we'll look at plate current. And it's about 12 milliamps. Sitting at about 30.25 or so. Okay, so we're going to try the noise now. Turn the input off and go turn on the AGC and bring up monitor level. And it sounds pretty quiet. I don't hear anything really rattling inside the tube. Just the standard kind of resonance of the glass itself. So like I said earlier, this is a lot of gain into that tube. If there was a loose grid, you definitely hear it. Okay, we're on filament EL84 6BQ5, and filament, I think we'll leave it right there at medium. This one also I'm going to give a plate voltage of 350. Okay, and the screen voltage is on low. Power tube, and the plate current is about 8.5 milliamps, and its gain, let me double check the oscillator here. Yeah, it's pretty good. So the gain is 35, 36, so it's got quite a bit more voltage gain than the 6V6 did. Okay, we'll try the noise on it. And ooh. That one's got quite a ring to it. I think it's mostly just the glass. I don't hear. Of course, if you had this near a speaker with that exact frequency that you're hearing there, it would definitely give you a feedback. So, you can also do 6 AQ5s here. And then I'm going to be making adapters for these plugs to adapt to some other power tubes. So that's the tube tester. It seems to be working pretty good. I have these tubes called Kendrick. I think they were kind of microphonic. So I just want to check one of those real quick. Filament on high. B plate will be 400. It's got a pretty good plate current there of about 18.2. Okay. And its gain is sitting at 34, just shy of 34. Now we're going to look at the noise of this thing. Got a little resonance there, but it is a lot of gain. All the power tubes are going to have some noise, so with this much gain, you're really looking for hiss and stuff like that too. This is the Kendrick. It's a little microphonic, but probably not too bad in an actual circuit, because this is really amplifying the this is mainly to find grid issues. This is mostly the glass itself resonating with that much gain. What you want to really look for is really some nasty grids banging together, or loose elements basically inside the tube. The glass resonance is just part of it. But if you do hit a frequency that's equal to that, you'll hear it. You'll hear it through the speakers as a feedback. And that's true with any tube. You get near it with resonant frequency. And the microphonic 12AX7s, like say in the front end of a Fender or whatever, will give you some major feedback sometimes. And some people like it.